Example 1, predicting from a linear approximation. Suppose that after you stuff a turkey, its temperature is 50 degrees Fahrenheit, and then you put it in a 325 degree Fahrenheit oven. After an hour, the meat thermometer indicates the temperature of the turkey is 93 degrees Fahrenheit. And then after 2 hours, it indicates 129 degrees Fahrenheit. We want to predict the temperature of the turkey after 3 hours. So first, if we take a look at our number line here, this is representative 0, this is 1 hour, this is 2 hours, this is 3 hours. And then we're going to go from 0 to 50 for the temperature, and then to 100, and then to 150. So let's first plot our points. We know that at 0, meaning that when we put the turkey, its temperature is at 50 degrees. So we know that we have this first ordered pair. And then when it's the hour, so once an hour passes by, we know that it is 93 degrees Fahrenheit. So about right there. And then 2 hours, it's about 129. So somewhere like around there. So therefore, this is representing our function. And so what we want to do is, this represents the function according to t. And then what we want to do is we want to find the linearization of that function. So that means we want to find this L that represents those points. So that's where L is located. So we're going to let T of t represent the temperature. At time t, or the temperature of the turkey after t hours. So what are we given? We know that t of when time is 0, we know the temperature of the turkey is 50 degrees. We know the temperature at 1 hour, the turkey is 93 degrees. And we know that the temperature after 2 hours, the turkey is 129 degrees. So now, in order to make a linear approximation with a is equal to 2, we need to estimate the derivative of t prime of 2. And so keep in mind that when we estimate, that means that we're finding t prime of 2 to be equal to the limit as time t approaches 2. And that is t of t minus t of 2 divided by t minus 2. So what we're going to do is we want to be able to find the rate or the slope. So what we want to do is we're going to let t equal 1, and then we're going to plug it in. So if we let time t equal 1, that's 1 hour, then what that means is we're going to get an approximation for the slope. So t prime of 2 is going to be t of 1 minus t of 2 divided by 1 minus 2. And we know that t of 1 is 93 degrees. We know that t of 2 is 129 degrees. And we know that 1 minus 2 is negative 1. And when we solve, we end up getting 36. Now this is 36 degrees Fahrenheit per hour. So therefore, that is the temperature average rate of change. So what that tells us is that T prime of 2 is equal to 36 degrees Fahrenheit per hour. And so we also have the order pair at time 2. The temperature of the turkey is 129 degrees. And recall from our formula that the linear approximation formula was equal to f of a plus f prime of a, which is a slope, times x minus a. So we're going to do the same thing here, only we're using temperature here. So the linear function, according to t, okay, is going to equal t prime of 2, or not t prime of 2, excuse me, t of 2 plus t prime of 2 times t minus 2, because 2 represents a in our particular formula. So now we can go ahead and plug in our values. So we know that L of t, or the linear approximation, is going to equal t of 2. Well, we know that t of 2 is going to be 129. So we know t of 2 is 129 up here, so we have 129 plus we know that t prime of 2 we found, which is the slope, is 36 times t minus 2. So if we simplify a little further, we get L of t, which is going to equal 129 plus 36t minus, we get 72. And so therefore L of t is going to equal 36t, and that's going to be plus 57. So therefore there is our equation. And so now what we want to do is we want to be able to predict the temperature of the turkey after 3 hours. So that means that for part 7, we want to say, okay, what does, when t is equal to 3, we're going to plug it into the function. So L of 3 is going to equal 36 times 3 plus 57. So we know that 36 times 3 gives us 108. And then if we add 57, we get 165. So we can then say that the predicted temperature after 3 hours is 165 degrees Fahrenheit. Okay. Now we can possibly estimate this to be a little bit more closer by just, estimating what that slope would be. So let me move this line here. This line should be going through those 2 points, right? Because that's the line that we end up finding here, was that line, because we were using those 2 points. But we could then predict this to be a little bit more, because you can see how this line is kind of underneath that function. So we would want to get that tangent, but in this case we're just predicting with those 2 points. And so therefore this is what we get by using the linear approximation.